This is MAC 1105, Section 1.4, a review of complex numbers. You should have seen complex numbers in Algebra 2 and perhaps 1033. So this is just a review. This is not all of the basics about imaginary numbers. You should remember that I is defined as the square root of -1. Before, if you took the square root of, let's say, -9, you had to say non-real number, and that was it. Well, now we have a definition for the square root of -1, and that is the square root of -1 is defined to be equal to I. Now, this is another fact that comes from the square root of -1 equals I, and it's that I squared equals -1. This is a very important fact that you will use as we do some simplifying. Now, the reason I squared equals -1 goes back to this fact. The square root of x times the square root of x equals x. So if I did the square root of -1 times the square root of -1, that equals -1. Well, what is the square root of -1? It is I. So I times I equals -1, and I times I, of course, is I squared. So you may not have to remember why it is, but it's an important fact that I squared equals -1. Let's talk about simplifying the square root of these negative numbers. The long way to show you the exact steps is to think about the square root of -25 being the product of the square root of -1 times the square root of 25. So square root of 25 is 5. The square root of -1 is right here. It's defined to be I. And of course, I times 5 is 5i. Now that's the step-by-step way to break it into its two factors. You can do this a little more quickly by thinking about the square root of negative is going to produce I in my answer. And then scribble out the negative and look at the square root of 81 is 9. So that's a little bit faster, and that's what you'll do as you get comfortable with this. These first two, the square roots were perfect squares. They came out nice and neat. With something like this, I have to take it one step further, and that is to think about, okay, the square root of -12 will produce I in the answer. The square root of 12, I would have to think about doing a factor tree on this. 12 breaks into 2 times 6, 6 breaks into 2 times 3. There's my pair, so I have a pair of 2's. So 1, 2 comes outside, and the 3 stays inside the radical. Now that's an okay way to write this. Just be careful. What I've always taught is to put the I in front here so that you don't make a copying mistake and carry your square root too far and make it look like that the I is under the square root. So I write 2I radical 3. On MATLAB, if you do 2 radical 3 and then hit your right arrow and put the I clearly outside of the radical, that's fine also. More of this, square root of -64, I would do an I because it's square root of a negative. Square root of 64 is 8. Minus, same deal here, we just did this one, this is 5i. Now I, yes, stands for the square root of -1, but this is just combining like terms. 8i minus 5i is 3i. One extra step here, I would put 5 outside parentheses and then do the rest of the work so that you don't forget to multiply by this 5. Square root of -16 will be 4i. Square root of -25 we know is 5i. And because we remember to put the 5 outside here, 5 times 4i is 20i, minus 5i, sorry, is 15i. Now a complex number is a number in the form of a plus bi, where a and b are real numbers. So something like 4 plus 6i is considered a complex number. It is in standard form. Standard form means that the I part is at the very end, a plus bi. So 5 plus 2i is in standard form. 6i plus 8 is not in standard form. I can put that in standard form very easily by just swapping those and making it 8 plus 6i. Now, a word about that standard form idea with MATLAB and how you enter things. Remember a minute ago I said I like to write the I in the front of the radical here so that it just doesn't look like the I is under the square root. Like that looks to me like the I is under the square root. But this is the form that MATLAB expects. So if you had 8 plus I radical 6, I'm just making up that value. Math Lab expects you to write 8 plus radical 6. Hit your right arrow to be sure you're outside of the radical I. That one is in standard form, a plus bi, where a is 8 and b is radical 6. Now, adding and subtracting complex numbers is just adding and subtracting your like terms, but be sure you put it in a plus bi form. Do you need to do any rewriting here? That's up to you. I can look at this and say 5 plus 7 is 12. Negative 11i plus 4i is negative 7i, and that's it. That is in standard form because the I is at the tail end. With a minus, you might want to do the extra step where you have 8 minus 11i. The minus in front of the parentheses tells you to distribute, so the 10 becomes negative 10. The negative 2i becomes positive 2i. You could, if you needed to, rewrite this so that your real numbers are together in front and your I part is back here, and then do the arithmetic. 8 minus 10 is negative 2. Negative 11i plus 9i is negative 9i. Same thing here, 3 plus 9i, distribute, negative 6 plus I. And remember, I is the same as 1i, so 3 minus 6 is negative 3. 9i plus 1i is 10i, and that is in standard form. So adding and subtracting complex numbers is very easy. It is combining like terms. Just be sure you have your answer in standard form, which is a plus bi form. Multiplying is a little bit more work. You're going to use distributive property or FOIL. If you just have something in front of the parentheses, this is just distributive property. 3i times 7 is 21i. 3i times 4i is 12i squared. Now this is where we have to use this I squared equal to negative 1. So there's two ways to do this. The longer way is to realize that I squared is the same as negative 1 and have 12 here and substitute negative 1 in place of the I squared and actually multiply this together. So this is 21i minus 12, which has to be switched around to be negative 12 plus 21i. Now that is a step-by-step way to do this. I teach this a little bit differently. So here's my 21i plus 12i squared. What I say to do, which is a shortcut, is to cross off the I squared and change the sign of the coefficient, because I squared is negative 1. 12 times negative 1 changes the sign. So rather than writing all those steps out, it's just cross out the I squared, change the sign of the coefficient. Now I can also get this in the proper order, so the negative 12 is in the front and the 21i is in the back. So cross out the I squared, change the sign of the coefficient in front of the I squared. Now that was just distributive property. This is just going to be FOIL. So 5 times 7 is 35. 5 times 4i is 20i. Negative 2i times 7 is negative 14i. And negative 2i times 4i is negative 8i squared. So I will cross off the I squared, change the sign of that coefficient. So that used to be a negative 8. Now it's a positive 8. Then I've got some like terms. 35 plus 8 is 43. And 20i minus 14i is 6i. And that is my answer, and that is in standard form. Remember, when you square a binomial, it's not just square the front, square the back. You need to think about this being 5 minus 2i times 5 minus 2i. Yes, there is a shortcut you can do in your head, and if you know that, that's fine. But what I'm teaching right now is just write out the binomial twice and FOIL. 5 times 5 is 25. 5 times negative 2i is negative 10i. Negative 2i times that 5 is negative 10i. Negative 2i times negative 2i is positive 4i squared. So with that I squared, cross out the I squared, change the sign on the coefficient. Now combine your like terms. 25 minus 4 is 21 minus 20i. Correct answer, and it is in standard form. These next two are special. You might remember the term the difference of two squares. And notice if you have binomial times binomial, when you're multiplying where the first two terms are the same, the second two terms are the same, and one of the parentheses is minus, one of the parentheses is plus, you can just do front times front. 7 times 7 is 49, minus 4i times 4i. 16i squared. Because it's I squared, cross off the I squared, change that sign, and we get 65. No I involved, just 65. Now, sometimes MATLAB expects you, or other software expects you to rewrite this as 65 plus 0i to indicate that it is in standard form. Double check, enter the 65. If MATLAB doesn't like that answer, you may have to enter 65 plus 0i. 65 is just fine with me. Same thing here, -5 in the front, 3i in the back, minus, plus. I can just do -5 times -5 is positive 25. -3i times positive 3i is -9i squared. Cross off the I squared, change the coefficient, and that gives me 34. Again, no I, but you could write it as 34 plus 0i if necessary. There's something called the complex conjugate, and that is when you have what we just did. These two things are the same. This is like that problem where we had 7 minus 4i times 7 plus 4i. We just did that one on the last page. Those are complex conjugates because they both have the same 7 in the front, the 4i in the back. One of the parentheses has minus, one of the parentheses has plus. Those are complex conjugates, and those are very important for us when we start talking about division. Now, let's look at this with the a and the bi rather than numbers. These are the same, so I can just do a times a is a squared, minus multiply bi times bi. B times b is b squared. I times I is I squared. Cross off the I squared, change the sign, and this gives me a squared plus b squared. And that's the reason, that's the proof really of why on these last two problems here, we ended up with just whole numbers. We really didn't have any I other than having to write 0i if that's what MATLAB wants.